Let's continue to practice polar coordinates by doing a couple of examples or a couple of calculations that will help us with examples we do in later videos for section 14.3. For the first one, let's see if we can find the polar coordinates for the points where the line x equals 2 intersects the circle x squared plus y squared equals 8. First, a sketch. X squared plus y squared equals 8 is a circle with radius square root of 8. So a circle with radius 2 square root of 2. And x equals 2 is a vertical line. So we can see from our picture that we're going to have 2 points of intersection. One point in the first quadrant and one point in the fourth quadrant. So let's begin by changing each of our two equations into polar coordinates. Remember, in polar coordinates, x is equal to r cosine theta. So this is the same as r cosine theta equals 2. Or if we wish, we can write that as r equals 2 over cosine theta. In other words, r equals 2 secant theta. So r equals 2 secant theta is the equation for the line. For the circle, x squared plus y squared equals 8. Remember the previous video, we saw that if x is r cosine theta and y is r sine theta, then x squared plus y squared is r squared. So we get r squared equals 8. So r is the square root of 8. Square root of 8 and negative square root of 8 give you exactly the same circle. We can simplify that as r equals 2 square root of 2. Notice that kind of makes sense. The circle is all the points whose distance from the origin is equal to 2 square root of 2. So if we want to find out where these two curves intersect, we can simply substitute one of these into the other. Since r is equal to 2 secant theta and r is equal to 2 root 2, then that means that 2 secant theta is the same as 2 root 2. Dividing both sides by 2, secant of theta is square root of 2, and taking reciprocals, cosine of theta is 1 over the square root of 2. Now remember, cosine is positive in the first quadrant and the fourth quadrant, so I'm going to have two answers. One answer in the first quadrant, which is going to be theta equals pi over 4, and I also have an answer in the fourth quadrant, which will be theta equals negative pi over 4. So putting these together, I'm going to have 2 points of intersection, using this as r, and those as my two choices for theta. So one is going to be r is 2 square root of 2, theta is pi over 4, and the other one is going to be r equals 2 square root of 2, theta equals negative pi over 4. Now where are those points with respect to our circle? One is going to be this point up here. This is the first point. Let's call that P. And the second point, Q, is this one down here in the fourth quadrant. Let's look at one more example. This is also a calculation that we'll need for a future problem. And let's say that we wanted to integrate over this region. I'm just going to draw a picture in the xy plane. It's going to be the region between two circles, a circle of radius 1, so that's x squared plus y squared equals 1, and a circle of radius 2, which should be x squared plus y squared equals 4. And like I say, I only want the part between those two curves and living in the upper half plane. Let's see if we can figure out what the corresponding region would be in the r and theta plane. Well, one possibility is to write the equations for all four edges. Here, we have x squared plus y squared equals 1. This one is x squared plus y squared equals 4. And the x-axis is the same as y equals 0. Let's convert the circle equations into polar coordinates. X squared plus y squared equals 1 is the same as r squared equals 1. So r equals 1. X squared plus y squared equals 4 is the same as r squared equals 4. So r equals 2. So notice that if I'm staying between the two circles, then r is staying between r equals 1 and r equals 2. So over in the r theta plane, I'm going to be staying in between the lines r equals 1 and r equals 2. Now what's happening with respect to theta? Well, over here on the positive x-axis, theta is equal to 0. Continuing counterclockwise, this is theta equals pi over 2. And then coming back over here, theta equals pi. So I'll be starting out at 0 on the theta axis and extending upward to pi. So this would be the corresponding region over in the r theta plane. Using the notation when we were talking about change of variables, this would be our r, and this would be the corresponding s. So if we were going to set up the integrals for this, instead of trying to describe this really complicated region using x's and y's, I can set up the integral using this very simple region in terms of s, in terms of r and theta. And notice that I'll just be letting r go from 1 to 2, theta go from 0 to pi. So I'm integrating over a rectangle in the r theta plane.